This is what it will look like when you are done. Ooh, and it'll hit the wall. We'll be able to click and we'll be able to change it to a random speed and direction, which are married in this case. But this is kind of neat. Anyway, this is just a little art project sort of deal that we'll make first. I find that this is a really good starting point to teach you about the XY coordinate system, moving things by affecting the X and the Y, applying speed. All right, everybody. So here we are, p5js.org. We're going to hit start coding down here, and it's going to take us to the web editor. Your web editor may look a little bit different. If you want to change the theme, I have the high contrast theme on right now, and that's just for you guys to be able to read it. The dark theme works as well. It's just not as like bright. And you can also do the light theme, which is default. I don't like light themes though. I think they burn eyeballs. They burn my eyeballs at least. So my text size is going to be up so that you guys can actually read the screen. That'll be up so you guys don't have to increase that at all. Keep autosave on, auto close brackets and quotes, keep that on. The autocomplete hinter sucks, and I don't like word wrap, so I turned both of those off. Okay, so here's what we're going to do. I'm going to kind of wait just a minute so that I'm not rushing everybody, because I have a tendency to move kind of fast. One thing I am going to do, I'm going to change this from 400 inside this right here in function setup to 500. I like to work with 500 pixels by 500 pixels. Basically, the difference is we could have a screen that is this size, or we could have a screen that is this size. And I like this size just a little bit more. I'm also going to change background 220 to 225. Actually, no. I'm going to change that to 0. So here is first lesson. It's about color. So colors in computers are very frequently, not always. There's a lot of different forms colors come in. But in this particular case, we're going to be using 3 numbers, R, G, and B. You'll probably recognize that as red, green, and blue because you're adults and you've probably heard this before. So we have, when we use a color in P5JS, we can send in all 3 right here into this background function. If I wanted the background to be red, I would put this first number at 255, the rest of them at 0, boom, red screen. If I wanted it to be yellow, I would turn on all of the green, mix that in together. And if I wanted it to be white, all of them would be 255. So if all of them being 255 is white, then all of them being 0 is black. And that's going to be kind of our chalkboard canvas that we're going to deal with. One thing I'm going to do, I'm going to add some space to my program to give us some room to breathe. I'm down here at the bottom. I'm just going to hold enter for, I'm going to put like, I don't know, maybe 20 more lines down there. Then I'm going to go up into the front of this function. On the left side of the function, I'm going to push all my code down a couple of times. This up here is where variables will live. We'll go over what variables are in just a second. I'm actually going to write out a note. I'm going to use 2 slashes. Oh. If there's one thing you'll be able to flame me for, it's my typing. I have really bad typing, especially if I'm focused on doing something else. So variables are going to go here. A variable, pay attention, a variable is the way a computer remembers things. A variable is a box. Imagine that you have a little cardboard box, right? And then on a piece of paper, you write down the sentence, I love tacos, right? You take your cardboard box and you take your slip of paper that says, I love tacos. You put your slip of paper inside of your cardboard box. Then on the outside of your box, you write the letter X. Now you can say, I have a box named X that has I love tacos in it. It has the sentence I love tacos in it, called a string. So that variable can then, I just have it. I can use it. I can take the sentence out of it and I can read it. And that can mean something to me. I can change what it says and I can put it back in the box and say, I love burritos now. Boom. I love burritos. No, we just started CD. All I've done is I've changed create canvas in here to be 500 by 500. And I've changed the background color to be black by putting 3 zeros in here for red, green, and blue, right? Here, I'll make a note of that up here. RGB. So now let's go ahead and take this analogy of a box being a memory for a computer, and let's have a variable that describes the X position of our box. So for JavaScript, I will use the keyword let. I will then name my variable, and the name can be anything that you want, but try to keep it simple and succinct. So we will say square capital X. This is called camel casing. Here's an example of camel casing. Camel casing is like this. Camel casing is where you start off the first word of your variable, function, class, whatever, or your first word of your variable or your function, lowercase. The rest of the words will be uppercase, will be capitalized words. So camel's the first word, that's lowercase. Then we have casing is like this. All of those are capitals. It's very easy to read once you get used to reading like this, and it becomes, this is what's expected. This is how all of your variables should look. This is how all of your variables should look. So we're going to name this one square, capital X. We're going to end our line with a semicolon. In JavaScript, this semicolon is kind of like the period on the end of a sentence in a book. It just lets the reader know, it lets the computer know, okay, I'm done with this line, I'm moving on to the next one. So let's talk about X and Y. Who remembers X and Y from algebra, right? The X and Y coordinate plane, you have 0, 0 in the middle, quadrant 1, 2, 3, and 4. Are all described by the combinations of X and Y inside of those areas. So the coordinate 1 is positive, positive, because you have positive on the X position and positive on the Y position. Now, here's what's interesting about the computer graphics. We start in the top left-hand corner at 0, 0. So imagine the coordinate plane, and then we are in coordinate 4, right? Bottom right-hand corner. We start with 0, 0, and we add to X to go to the right. Right? So we go from 0, and right now we're going to 500. So we start from 0 here, and we go all the way to 500. That's 500 pixels for the X position. 500 possibilities for anything to be there. Color, shape, collision, whatever. Now, what do you think the second number might be? It's Y. However, unlike the fourth coordinate, we are not decreasing. We are not going negative. We are going positive. So this is the first weird thing about computer graphics. When we are adding to Y, we are going down. When we are subtracting from Y, we are headed back up towards 0. So 0 is at our top. 500 is at our bottom. That's really important to understand. So we have our variable. Right now, remember how I said we would put like a sentence inside of our box for a for it to be a for it to hold, to remember the sentence? Well, right now we've just made a box. We haven't made it equal anything. We would need to use the equal sign, or the assignment operator, as it has a fancy name in computer science. And we could make this equal 250, right? So we are taking the number 250 and we're putting it inside of our square X variable. That means that square X, whenever we draw this square, it will draw at the 250th pixel on the X axis, which would be right around here. Right in the middle, because we have 500 pixels, we're going to start at 250. So great. There we have that. Let's go ahead, and because we know that we're going to need to also remember the Y value of whatever we're doing, let's go ahead and add a line. We'll use let square Y equals 250. Very similar. The very important difference is the name. We want square Y to be a different name than square X. You can even just call these X and Y, but they need to be descriptive so you know what they do. Because later, if you're 500 lines down in this code, mucking about doing something, oh, I need to remember to draw that square. What were the names of the variables again? Was it X? Was it X square? Was it square X? Was it? It's much easier just to remember, just to make them right off the bat, square X. That's exactly what it does. Okay, let's actually get to drawing something. You notice that when you opened up your editor, you already had this code in there, right? You had a setup function that had create canvas. You had a draw function that had background in there, right? Setup is the function that is called once you press the go button. It is called once, and everything in it is run. So what that means is that you can imagine the setup function like the construction crew building a building. We hit the go button, construction crew comes in, takes all of the pieces that we give it, builds the building, and leaves. That's the setup function. It does one thing one time. Now the draw function would be like the business that goes on inside of that building. It does stuff every single frame. That's how video games work if you don't know. Frames per second means that you are rendering, calculating, and redrawing. Well, that means the same thing. You are calculating collision, satisfying that collision, updating the physics, and redrawing everything in a frame, right? So that's all the stuff that happens in it. And then that's not tight by law. There's some things that take several frames, some things that skip, whatever. I'm not talking about that. I'm talking about this draw function is going to be called and run 60 times a second. Okay. So if we want to draw anything on the screen, we need to make sure that we do it in the draw function, right? Let's go ahead and draw our square on the screen. Okay. Let's go ahead. We will say inside of our draw function, underneath background, we will say rect and parentheses, right? So rect stands for rectangle, which means we are about to draw some sort of a square-ish shape. It's going to have an X and a Y, a width, and a height, and that's all we need to know about it, right? So how about we, just for right now, let's say put 20 in the function call 4 times. So we are inside of these round braces, these parentheses. We'll say 20, comma, 20, comma, 20, comma, 20. Okay? Perfect. You can run your code, and you can see that we have a little square up there. And let's go over what this means now. So this, X, Y, width, height. Okay? We are at pixel 20 on the x-axis, pixel 20 on the y-axis, starting from right up here, this top left-hand corner, that's 2020. We then tell the computer, I want you to go over 20 pixels, and I want you to go down 20 pixels. And I want you to finish drawing the square. I want you to connect wherever on the board, or wherever on the screen those 4 points lie. I want you to draw a line between them and shade it in white, I guess. White is the default. The variables haven't come into effect yet, so if you feel like these are useless right now, they are. We haven't used them yet. We are going to very shortly. So let's change some things up really quick. Let's go ahead and add 2 more variables for width and height, because we know that we're going to want width and height, and what I don't like to do is what's called magic numbers. Magic numbers are when you hard code a number somewhere in your code. Imagine you're making a game, and this script is for like just one little piece of your game, but it's a sizable piece, but it's a piece nonetheless. And somewhere months ago, when you were first developing the class or whatever, you decided to use the number 16. Well, now 16 doesn't mesh with how the scale of your game has changed, and you need to go find it and change it. The only problem is you don't remember where it was. And now you've got 600 lines of code to search through trying to find that one magic number, when you could have just said, let num equal 16. And then you could come up here to the top of your screen and say, oh, it needs to be 18 now. So that's the big difference there. So let's go ahead and make, we're going to say let square width. Remember our camel casing. We're going to say actually 50. Let square height equals 50. Okay, we're gonna have one variable named square width, one variable named square height. Let's go ahead and use these top two variables. I'm gonna wait for everyone to be able to kind of type this out and everything. We're gonna use these top two variables in the X and the Y position in our rect call, okay? So here's what we're going to do. This first 20 right here, replace that with square X. Now let's just go ahead and run our code and see what happens. And before I run the code, imagine what you think will happen. We just took the number 20 and replaced it with a variable whose value is 250. So when we run the code, our square has teleported to the middle of the screen at the 260th pixel, 250th pixel. So now let's do the same thing with the second 20. Second 20, we're going to replace with square Y. Boom. And now you're saying like, wait, but it's offset. This isn't the very center of it. It should be the center. It is. It is. We are drawing our rectangles from the bottom, from the top left-hand corner. So this spot right here where my mouse is the very center of this game screen. We are just having the hangoff of 20 pixels by 20 pixels. Made it a ball? Hell yeah, dude. You can make it a circle, you can make it an ellipse, and you can affect how like big and wide it is. 250 lower. Okay, so now let's go ahead. What you're probably going to imagine, we're going to change the width to square width and the height to square height. Now, rerun your code. And we have a much bigger square. Now, one thing I like to do, I'm going to throw one more parameter in here, one more argument in here. I'm going to throw the number 5 right at the end of it, because that's going to round our corners and just make it look a little bit cooler, I think. In my opinion, it looks a little bit better. Anything that is not a circle is by default drawn from the top left-hand corner. You can change the mode to draw and anchor everything from the center. It's as simple as coming in here and saying rect mode and then passing in a constant like center. And that actually, if I do that and I run, now our square is exactly in the middle of the screen. However, I don't like to do that because that messes with how I explain collision later on. Because we are about to start moving this, right? We are about to start making this go. Who wants to do a little bit of animation? Let's go back up to the top of our script. Let's say let square X speed. We're going to have that equal 3. We're going to make another variable, let square Y speed, right? Just like we did for the X and Y positions, we're going to make an X speed and a Y speed because you want to affect your speeds independently. You want to affect your coordinates independently. Because if I am moving at a wall like this, I hit the wall, I want to basically invert my X speed. I basically want to mirror my X speed so that it goes this way, right? It's mostly heading this way. I want it to mostly head that way again. But if I just have a regular speed, I'm going to go backwards because I'm going to, the Y position is going to flip as well. So I want Y to remain going up while X goes the other way. So now we have square X speed and square Y speed. These are really low numbers. Do you know why that might be? So the reason we have two variables that are relatively low is because we want to translate the X and Y by that amount every frame. So if you are a character that is 10 pixels wide and you want to walk to the left, you don't want to move 10 pixels at a time because you'll snap. You want to move 3 pixels at a time so that it's more, so that's smoother, so that it looks like you're moving instead of snapping to place. So what we can do is, because we are using square X and square Y, this is really important, folks. The reason we are using square X and square Y here is because we can redefine them to be whatever we need them to be. Okay. This is a really weird thing that I just did. We wrote the words square x plus equals square x speed. Now, the plus equals is a special arithmetic operator, right? Here's what it means. It means we're going to take square x, what it equals right now. We're going to set it equal to the sum of square x speed and square x. These lines are equivalent. These mean the same exact thing. This is just a shorthand. It just means take what's on the left, add what's on the right to it, and set it equal to that sum. That's all it means. Oh, sure, like over here. Sure, we can do that. Yeah. Okay, so let's go ahead and see what happens when we run our code. We have animation. We have a square that trots off by itself. What do you think we should do next? My square ran away from me. Well, let's turn it a little bit so that it runs away from you from a different angle. Square y speed. Okay, we're going to do square y plus equals square y speed. We're going to add to the x and then the y and then the x and then the y and then the x and the y. So we're going to add to the x, we're going to add to the y, we're going to draw the square. We're going to end our draw loop, we're going to go back. One thing that I'm actually going to do that's a little bit more fun, I'm going to copy and paste this background call. I'm going to take that entirely and I'm going to put it inside of my setup function. Now watch what happens. Now we have a trail that leads off because we are no longer clearing the background, clearing the screen and drawing the background every frame. We do it once at the very beginning of the screen or at the very beginning of the program. So we paint the backdrop black and then we draw everything over it over and over again, right? So that's the difference there. And we're going to keep it like that too because it looks nicer. It looks way nicer. Now, let's go ahead and do collision. We're going to do collision. Normally, I would do a separate function for collision, but because we're just starting out, I'm not going to do that. Here's what I am going to do. We are going to now make the square bounce off, or whatever your shape is. We're going to make your shape bounce off of the walls, okay? So how do we do that? Well, just like I was explaining before, whenever we have an object moving towards a wall, when they meet, all that needs to happen is the inversion of the speed that is the culprit for the collision. So if I am headed this way and I meet a wall, I want to invert my x speed so that instead of adding 3, I'm subtracting 3 now, right? So that I move back to the left. So how about we use an if statement to check where we are on screen? Let's type the word if and some round braces, some parentheses. Inside of this if statement, we're going to ask the computer a question. That's what if statements are. You ask the computer a question with an if statement. You can ask a series of compounded statements or questions. You can call functions and see their results and ask questions based on that. But this is at its bare bones. What up, Dad Core? Yeah, dude, we're programming. But at its core, an if statement is a question. So the question we're going to ask is if block X is greater than 500. Okay? All we're seeing, basically we're asking, is the block off screen to the right? Okay? Is because remember, if we have, I don't think this will run. Yeah. Anyway, I just needed the screen. So if we're here, if our X position, which is the top left-hand corner of our square, if it's touching this side, we are off screen. We want to go the other way. So what we need to do now, put curly braces down, right? Curly braces are above your enter button. shift, and they're the secondary character on your square brackets. Hit enter. So that it looks like this. It's all nice and nested and everything. So if we are, all we're going to do is we're going to say square x speed times equals -1. Now, here's what that does. Again, just like plus equals, times equals takes what's on the left of it, multiplies it by what's on the right, and sets it equal to that. If we times equals by -1, all we're doing is inverting the speed. Let's see it work. So let's go ahead and run it. What happened? Oh, it's block. I meant square. I meant square x. Square x greater than 500. Boop. And there we go. But I'm going to go ahead and go over this with you guys because I think I'm not teaching kids, so you guys have the capacity. Do you notice how we went off screen behind my head? Like we went off screen here. Normally, we would want to check if as soon as we touch the wall, not when we're past the wall. So what we're going to do is we're going to do a little bit of arithmetic in here. Instead of just checking for square x, we're going to check the position that is this corner. We want this corner, right? And what is this corner? This corner is just x plus the width of the square. That's it. So if we check to see if square x plus square width is greater than 500, and then we flip, we're essentially checking sooner than we would normally, right? We're saving a little bit of time. But we are going to next do the y direction. Okay, let's do underneath that if statement. Let's do another one. You'll see. You'll see. You'll see. You'll see. We're going to say square y plus square height, right? Because we want to use the y axis this time, is greater than 500. Square y speed times equals -1. Okay? So here we go. This should make us bounce off the bottom of the square. Boom, boom. Nice, clean, simple, easy. But now we need to check 2 more sides. So here's what we could do. We need to check if square x and square y are less than 0. I'm going to go ahead and unveil that mystery now. We need to check if those numbers, raw numbers, are less than 0. Here's what we could do. We could copy and paste this down. And then we could take this out. And we could say less than 0. And then we could take this out. And we could say less than 0. And it would all work. It would look bad, but it would work because why we have one question we're asking one question that we are asking the computer. The consequence is multiplying the x speed by -1. We have another question very much related to the first question that has the same consequence. Let's compound those together using an OR operator. So instead of this, I'm going to leave this here so you can see it, but I'm going to go back up into my first if statement. Space. I'm going to use the pipe operator, LOL, giggity, which is the key directly above your enter button. Shift, put 2 of these pipe operators down. This lets the computer know I want to check not only if square x plus square width is greater than 500, but also if square x is less than 0. If either of these is true, invert the x speed. If either of them, not if both of them, if either of them are true. So x could be less than 0 or x plus width could be greater than 500. Either way, it's the same exact thing. So I'm going to go ahead and get rid of this if statement. Right? We're going to do the same thing over here. We're going to say or square y is less than 0. We're making Zelda right now. See, watch. Look, this is practically Skyward Sword. Ladies and gentlemen, congratulations. We have a working screensavery type of art project kind of deal, but it's not super great yet. It could use a little bit of color. So let's go ahead and do that. One thing we can do right off the bat, let's go to our setup function below our background, actually above our background. It doesn't actually matter where you put it. We're going to type the word no stroke, 2 words, no stroke, camel cased with parentheses. This is going to remove the outline from our square, which looks a little bit cooler in my opinion, right? Okay. So we've got that going. That's really cool. Let's talk about color again. We talked about color being R, G, and B, right? That's the default mode that color happens. But what we would rather do is after this, type the word color. Oh, what's going on, Rem? Color mode. HSB. Let's make another variable. This time we're going to affect the hue of the color. So here's what this did. Typically the color mode is RGB, which means first number is the red channel, second number is the green channel, third number is the blue channel. You mix and match up to 255. HSB is hue, saturation, and value, or boldness, something like that. I don't know. It's a little bit different than HSV. Essentially, H is your hue, which is your color. S is your saturation, and B is like the intensity of your color. So what we can do is we can cycle through colors using only one number, which is what we're going to do. We're going to make it rainbow. So let's have a let hue equals 0. Okay. So we're going to make that variable at the very, very top. One thing we are going to do, Eb, since you suggested the random path, is that we're going to make it when you click your mouse, it will randomize the speed and direction. Okay, so now we need to introduce a new function in our draw function, new call to fill. So we need to say fill, F-I-L-L. This is the, imagine you're using Photoshop or GIMP or something like that, some photo editing software, image editing software, and you get the bucket, like the fill tool. That's what fill does. Fill will fill in any shape or text with the color you pass in. So let's go ahead. We will say fill, we will say hue, comma, 100, comma 100, I think. And if that works, then your cube should be red. Your square should be red. Yeah. Yeah, I know what I'm doing. I know what I'm doing. Okay. Now you're saying, well, great. That's a beautiful, beautiful red square. But what about the different colors? Let's go ahead and make it rainbow. So what we can do is we can cycle through all the colors by simply saying hue plus equals 1. Go ahead and run the code. Hue plus equals 1, run the code. Let them see it. Let them see it, chat. Oh, beautiful. Oh, beautiful. Oh, beautimus. But now you're saying, well, wait, I was seeing beautiful rainbowy goodness, but now there's just red, angry, biblically accurate angel. And to that I say, yes, we need another if statement. So below our hue plus equals 1, we will say if statement, if round braces or parentheses, hue is greater than 360. Then put our curly braces down. So if we are asking the computer if the variable hue is greater than 360, all we want to do is set hue back to 0. Okay? All you have to do is rerun it again. By the time it gets to red, it will go right back down to orange and 0. And this will continue in this way forever. That is the main crux of this program. That is the main deal. We're going to add a one or two more features using a new function called random. Random, as you can probably imagine, is going to randomize the direction. So let's go ahead and do that. We can start these. We can keep these the way they are, the square x and square y speed, but let's go down into setup. Back in the setup function, we're going to set square x speed equal to, like the word random, not random, like I do all the time, random, and then round braces, okay? We are calling the function random. We're going to pass in -3, comma 3. Here's what random will do. Random will take the first number and the second number and find a random floating point value in between the two. So at the very least, x speed will be -3. At the very fastest, it will be +3. But it could be any number in between, up to like crazy precision, like 32, no, like 16 places after the decimal. It's wild. So basically what we're saying, we want a random speed for x. Hell yeah, Rem. I spend most of my time finding stuff like that at work. I guarantee you guys aren't making any big mistakes or doing anything you're not supposed to. I guarantee everything that's happening is normal. So now we have square y speed also being -3 to +3. So if we start, oh, that's a different angle. That's a different angle. It's a different angle. It's a different angle. Woo! All right. That's pretty cool. So one thing I like to see is also being able to change the path, because the path gets very obvious after a while and not very fun to watch. So how about every time we click the mouse, we do this. So what I want you to do really quick, copy these guys. Copy just these two lines, Control C. We're going to paste them in just a second. Let's go down under function draw. We're going to type our first new function. This function isn't a custom function we're making. This is a function that's built into P5.js. Okay? So let's type function, the word function, mouse lowercase, pressed uppercase. Mouse pressed. Then we end with round braces like these, parentheses, and then we put the curly braces in. Okay. So here's how it works. P5.js will look for the mouse button pressed. We'll look for any mouse button pressed when this function is called. When this function is present, it will look for your mouse buttons. And if one happens, it will run whatever code's in here. Inside of this function, hit Control V. That's it. Run your code. Ooh, that's a good angle, and that is a good speed. I like that. But we're going to click. Ooh, really slow. And we're going to click again. We're going to click again. We're going to click again. And now we can make kind of like more interesting shapes. You know what I mean? And that's it, folks. That is this whole program done. We learned about variables. We learned about functions. We'll learn way more about functions in the next project we make. We learned about random numbers. We learned about speeds, X and Y, moving things around, and we learned a little bit about collision. Is it possible to make it change direction every X seconds? Yes. How about we make it change every 1 second? So up here in draw, I'm going to add another if statement. I'm going to say if, and I'm going to use a built-in variable called frame count. Frame lowercase, count uppercase. Frame count is a built-in variable that is the number of frames since you pressed go, right? So if I have the number of frames that has been processed since go, since go, I can modulate that number and say, okay, well, if I divide this number, if I divide frame count by 60 and the remainder is 0, that means we are on we are at an increment of 60 frames into the program, right? Which is a second. So if we use the percent sign, and that's called the modulus operator. We use the modulus operator, so we say we're going to take the modulus 60 of frame count, and we're going to check equals equals equals. You don't have to do 3 equals. I do 0. Early braces. Okay. So if the frame count divided by 60 has a remainder of 0, change the speeds. So let's see how that works. Oh, that's not every. Oh, yes, it is. That's every second. I'm going to take a break, and then we're going to come back and we're going to build Flappy Bird, which again is over here.